Hello, my name is Evan Hamaoka, and welcome to a series about AP Computer Science A. This is our first video in the series, and today's lesson will be about Java basics. First though, why should you take AP Computer Science A? Well, for me personally, I have a humanities background, and Comp Sci has nothing to do with my intended major, which is political science and government. But Comp Sci is really eye-opening. It's like literally learning a new language. It provides you with a new way of thinking and helps you see the world differently. This last school year, I took a class AP Computer Science A at my school, and the AP test itself with no prior programming knowledge, and I got an A in the class, and I passed the AP. I would still consider myself a beginner, but here goes. I'll teach you the course nonetheless. All right, so AP Computer Science A teaches Java, like I said, a language that we will run through the coding application Eclipse. It looks like this. It looks like a little blue moon crossing over the sun, like an eclipse. So first, once you've downloaded Eclipse, we will start by creating a project. So file, new, project. We can name it whatever. So, we press next here, and then project name. So I don't know, YouthSTEM 1. No, just YouthSTEM. All right, and then once we've created the project there, we can start by creating classes. So new class, and then a class is basically what you'll execute code inside. And so we can name it whatever, test number 1. And then so it will be inside the folder YouthSTEM, which is the project we're in. You check the box public static void main string arg. So that's like basically the core method of a program. I'll get to methods in a little bit and where the program starts. So anyway, and the words let Java know that this is your starting point for the class. All right, so after that, you're free to start creating code. Boom. All right, so there's a class name, and then there's the void. And we have to also notice that you have to sandwich all your code between like an equal number of inward and outward facing parentheses. Like we have 2 here, and then we have 2 down there. And then you see if you click this one, it highlights the one it corresponds to. And if you don't have an equal amount of inward and outward facing parentheses, or brackets as I like to call them, the class won't run. So anyway, the first code we'll be experimenting with this in this course are print statements. Print statements are written with a syntax system.out.print. This is the text that will be printed out. And then so once we run that in Eclipse, we can do system spelling print, and we have to bracket it with quotes. So this is the code that will be printed out, and then we have to enclose it with a quote, and we need the parentheses around it, and we need a semicolon after. This is important. A semicolon basically like just marks like this logical end of a line of code. So like when we run it by just clicking the run button up here, this is the code that will be printed out. All right, that's pretty good. And we execute the code by pressing run. As I said, code is executed top to bottom. So the open box at the bottom of the screen here is referred to as the interface. The interface down here. And then whatever's inside the quotes prints there. If you want to clear the interface, press the red X button as this. And all right, for printing, if you want to print the statement on a separate line, just add ln after system.out.print, and this looks like so. You would do system.out.print ln. I want this code on new line, and then we need the semicolon after. The semicolon is very, very important. You'll need a semicolon basically after every statement you declare in Java, except for for loops. We'll get to that in video 3. So when we have these run, there goes. Man, what? Print ln. There we go. All right, yeah, there we go. So we have these on separate lines, and if you didn't do that, if you took away these, they just kind of meld together. All right. Yeah, and we don't want that. Variables. In computer science, like mathematics, variables are extremely important. They also must be a specified data type. For this lesson, we'll start with what's called primitive data types. But first of all, variable declaration. Variables in Java will be declared in the format type identifier equals data. For example, int youthSTEM equals 10. The data type is an integer signified by int. The variable's name is youthSTEM. But you can name it whatever you want. You can name it xqn or something, or like mmmm, or like 09, just whatever you want, as long as you can recognize what it is and type it out. And the actual value stored by youthSTEM is 10, and we need a semicolon at the end. And so in the next slides, we will discuss the different data types in Java. So the 4 most important types are here. Int is the first one you learn. It holds one integer between, I don't know, -2 billion and 2 billion. So For instantiation, some things work, and declaration, some things work and some things don't. So if we're making an int called lighthouse, this works. It's able to equal -53 because that is an integer with a semicolon. We need a semicolon at the end just at every one of these. See, but if we're doing int Jeremy equals 19.56, this doesn't work because 19.56 is not an int, it's a decimal. If you want to express decimals, we would use the variable type data type double, which holds one decimal. And you can enter integers here too, but if the number is 5, it will be printed as 5.0, for example. And so we can do double cent equals 100.0, that's perfectly fine. We can also do double 100 equals 100, and that's perfectly fine. Just for example, if we do like double 100 equals 100 here, and then if we want to print 100, the interface will express it as 100.0 because it's just inherently by being a double. But if you want to do something like double stuff equals a, it doesn't work. It doesn't do anything. So like there's a specific error message for it. If we were like doing like double stuff equals a, that doesn't work at all because well, it's not a number. We can't do anything with it. So anyway, Boolean is a binary data type that is only able to store one of two values, true or false. It's most often used to store yes or no data. So Boolean oui, for example, equals true. That works. Boolean non equals false, which also works. You can name these whatever you want. It doesn't have to have an allusion to the concept of truth or falsehood. Like you can name it literally whatever. You can name Boolean wrong equals true if you want, just to be facetious. But and you can't do something like Boolean fence sitting or Boolean whatever equals maybe. That doesn't work because maybe is not the value true or false. In Boolean, there is one of two values. And so anyway, char is used, or char is used to represent any single character that can be typed in a keyboard. Numbers, lowercase letters, capital letters, and even symbols. So we can do something like character equals F. We need to enclose it in single quotes like this. We can do like, I don't know, character equals, we need single quotes to bracket it and the semicolon after the last bit of single quotes. And then if we want to print that, we were allowed to do it. And then, but if we wanted to do something alternatively, like char guess equals, I don't know, F8, and then system.out.println guess, we're not allowed to do that. And so you see that here there's a red X signifying an error message, invalid character constant. A character can't be, it can't have two characters in it. It only holds one character, hence the name. And so, oh yeah, right. I want to execute the code to prove that. Actually, no, yeah, we can't even run it. So, but if we delete this portion, we're able to run character. Yeah, there we go. And this doesn't run because it's an invalid type. So anyway, there's 4 less used variables in Java. These are byte, short, long, and float. These are all for number storage. Byte, short, and long can store integers of varying ranges, byte having the smallest capacity and long having the longest capacity. While float can store decimals in some specific cases, there are some restrictions, like the biggest number a byte can store is 128 and the smallest is -128, but you really don't need to know that right now. I don't really ever remember using any of these 4 in class, nor for any really practical application. For naming conventions, the primitive data type, like the word int or boolean, will always be expressed in lowercase, as you can see here. Like we do double, and if this is capitalized, that's wrong. We can't do that. It doesn't recognize it, so we need the lowercase. And the conventions for naming variables are that the variable should start with a character that is in the alphabet, and the variable cannot be named something like that would cause it to be mixed up with something like a data type. So for example, you can't name your double variable int. That won't work, nor would you want to. If you want to print the value of the variable YouthSTEM to the interface, you would simply do system.out.print YouthSTEM. You can do it like, I don't know, system.out.print YouthSTEM. You need to have the same case in capital letters, and it will print 10 to the interface. There we go. But say if you wanted, like, if you don't put any quotes around the word YouthSTEM, if you want to print the value, if you put quotes around it, even if it does match exactly the name of the variable, just doing this will execute as a normal print function, and it will print the words. It print the word YouthSTEM. So anyway, question time. Fill in each blank with a proper data type. And we will only use int, double, char, and boolean for these questions. Remember, the format is type identifier equals data, semicolon. And so I'll give you a second. Just think of what type these data declarations would be. You got it? All right. So that wasn't too bad. So following the thing type identifier equals data semicolon. So we see what's stored actually there is a character, and so that has to be char. And Lenny equals true, and booleans only can take true or false, and so that's going to be definitely a boolean. Negative 4.32 is a decimal; it can't be an integer, and so it's a double. 25, I mean, it could technically be stored as a double, but then what makes most sense is storing it as an integer, because if you wanted to make it explicitly a double, you would put 25.0. All right, but now let's back up a little bit. We've done variables, which is the introductory thing, but now let's back up a little bit to the bigger picture, the fundamentals of Java. First, we need to talk about classes and methods. So a class is a blueprint for creating objects, essentially. Classes don't, all code has to be run inside of a class. Classes don't actually have to be runnable, though, nor do they need a main method. However, like for the purpose of our course, we will have all classes be runnable and have a main method. And so an example of that of a class is like, the one we made earlier. It's inside the YouthSTEM folder. It's test number 1.java, and the name is test number 1, public class test number 1. And so a method is a storage location for related program statements. It only runs on demand. When called, a method usually performs a specific task. Methods are defined inside a class. They have to be. And a method header is similar to a class header. I'll show all that in a second. So anyway, once you have instantiated an object, you can call the method and it will do the thing described in the code of the method. Methods can also take in parameters, execute their code, and return a value. So for example, we're going to create a method that is designed to get area. We're actually going to call it a get area. So I'll break down the little keywords in this in like 1 second. But first we have public static double get area. It's going to be called a get area. Sorry, we don't need a parenthesis either. Get area. So what is area? Height times width. So double width and double height. We do not put a semicolon here. Inside this is the formula for area, and so we can do it returns. We need the keyword return. Return width times height. We need a semicolon here. All right. And so what does any of that mean? So this is the same method. It's just an example. So this is the modifier. This is the return type. This is the method name, and this is the parameter list. And these two are known as the method signature. And this is the method body, which returns what we want. But what does this mean? So the first one is public, the modifier. The modifier controls access to the method. Public methods are accessible by all classes in the Java project, while private methods are only accessible in the class where the method is instantiated. For our course, we're only going to use public methods. I don't think I've ever used a private method in this course. So anyway, the return type is the data type that the method returns when it's called. So we return width times height. Width times height will be a number. It won't be like a boolean or something. So we put it returns a double. So just so it's more precise, like we can put in doubles here and it will return a double. It can be any data type. Well, okay, for a general method, it can be any data type, such as the primitive types we listed earlier, such as int, double, boolean, or even character. Or it can be void, meaning that the method doesn't return a value inherently. This is usually accompanied by a print function, making it return something. And so the method name here, getArray, this is part of the first part of the method signature. The method name is what is used to reference the method in the code. All right, you got that? And the parameter list is a list of requirements that the method must take in order to be called. Anytime getArea is called, it must have a width and a height double in parentheses after it, like getArea 8.0, comma 9.0, semicolon. And so if we want to execute that code as a working example, and so we have the method up here, we have public static voids, we can run the code inside of it. And so I don't know if we can do a print function for just an easy area calculation system, but .println area of rectangle 1 colon plus, okay, this is just this is just a little part of the method. Sorry, not in the method, it's part of the print function. And we do get, this is the important part, get area, and then we need to have two parameters. We need to have a double for width and a double for height. And so we can just do doubles here, 2.0, 7.0, and a semicolon afterward. And doing this will jump back up to the getArea function. So our width double is 2.0, our height double is 7.0. So it'll multiply the two and return a value, which is a double as indicated here. All right, and this will run 14. Okay, little spacing error. Okay, and this marks the end of video 1. However, if you would like to see the execution, the classes, and the methods, and everything of a real game made in Java by our very own Alan Huang, you should watch video 1.5. However, it uses some advanced topics such as arrays and strings, which are found in videos 4 and 2 respectively, so you may want to watch the rest of the course and then come back to video 1.5, or you can just go back right to 1.5 and then watch it for what it is. Your choice. Alright, thank you for watching.